Okay, today we'll be doing a problem related to normal distribution in which we'll be finding out the sample size, okay, for some confidence interval. So this is a SAT scores are distributed with a mean of 1500 and a standard deviation of 300. So we are considering this to be population mean and population standard deviation. You're interested in estimating the average SAT score of first year students at your college. If you like to limit the margin of error of your 95% confidence interval to 25 points, how many students should you sample? So we want 95% confidence interval and the error is 25 points. Mean is simply 1500. Standard deviation is 300. Okay. And we would like, so here, since we know that we want 95% confidence interval, so alpha equals to 1 minus 0.95, that's the 95%. Okay, so this is 0.05, then alpha over 2 would be 0.05 divided by 2, which is 0.025. Okay, so that's fine. Now we all know that error based on mean is z alpha over 2. So we need to find the z score. Okay, we want to find the z score, and here in the question it is saying that what is the sample size that we need to choose. Okay, what is the sample size? So for that kind of sampling distribution, the standard deviation should be divided by the root of sample size. Okay, so this is the formula that we'll be using. Okay. All right, so now first of all we will go for finding out the g alpha by 2. Okay, g value, g alpha by 2 is g 0.025. now here we need to realize that since we have already assumed in the question that this distribution is approximately normal, the mean is given, population standard deviation is given, so now now we can use the standard normal distribution to find out the g values. Okay, now standard normal distribution means its mean is 0 and the standard deviation is 1. So now let's head over to this website geogebra.org/classic-probability, and then let us either go for left tail or right tail and just choose the numerical value. Okay, so let me go for the right tail, and in this space you write down 0.025, and then you can see that this value is 1.96. this is the 0.025 area, right? Okay, so 1.96, let us write that down. So this is 1.96. all right, so what was the deal is, if this is the distribution, then 95% confidence interval means this will account for 0.025, this will account for 0.025. okay, so this is alpha over 2, and this is also the same thing, 0.025. okay, so that's it. All right, so we figured out the z value, the value somewhere over here or here. Okay, all right, so that's it. And now let us work with this equation. Okay, so let us work with this equation. So for that, let me just throw it over here. So error based mean, so error, we need to limit that to 25 points. Okay, so let's go for that. So this is 25 points equals to g alpha over 2, we just found it out, 1.96, right? So that's the thing, times sigma was what? Sigma was 300, right? So that's 300 over there, and root under n is just over there. So the only thing that we need to do is we need to solve this equation and find the value of n. Okay, the sample size, right? Okay, so for that, what I will do is I will simply interchange this root n and 25. Okay, I'm just cross multiplying them. Okay. So cross multiplying them will give me root n equals to 1.96 times 300 divided by 25. Okay, so that looks good. So now let us work on this one. So this is simply 1.96 times 300 equals to this much divided by 25, that's 23.52. So that's root n equals to 23.52. Then next what we need to do is we need to square both sides. Okay, let's square both sides. This will just cancel out the square root on the left hand side, and thus we will be getting n equals to what? 23.52. 23.52, let us square it. 553.19. So that's 553.19. Since this is the sample size or number of students this is number of students, so that's why I would approximate 554. Okay, so that would be the sample size that we must choose such that the error is 25 for the confidence interval 95%. Okay, so that's how we find out the sample size, and this process holds for students t distribution, proportion distribution as well. Okay, thank you.